I have one message before I start the presentation, and the message is basically we don't have a technology problem, we have a governance problem. So there are a lot of amazing solutions available, especially, and I'm now concerned about climate change mitigation. We have a lot of technological options available, but what's not working is the governance of that. We need to get out of coal, gas, and oil as quickly as possible. The institutions lined up are stacked against that endeavor. We have an institutional problem, and the solutions, like, for example, including specific AI applications, they are mostly existing. And the problem is like directing these solutions for mitigation benefits, which alone, which is actually happening, but it's alone not enough. It's also about limiting the applications to climate harmful activities. And this is, again, it's not an issue of technology, it's about the governance of technologies. So that's my major message, and like all, I will go a little bit to detail and give like a larger framework of that, but that's really the bottom line. Yeah, I know I wanted to start talking without my slides, because otherwise you just look at my slides. I will now share my slides. But I need the permission to share my screen. So if the host could please allow me to share my screen, that would be good.
You should have access now.
Yeah, thank you. I now have it. Can you see my screen? I assume yes, if I don't hear otherwise.
Yes.
This is now my short contribution. I will talk about the big picture of the Anthropocene and then focus a bit on urban scale solutions, because this is, from my point of view, specifically interesting. One point is that one can see digitalization as basically as a continuation of existing ICT, information and communication technologies, with a starting point of scripture, of course, like it's a very long time ago. But one of the bottom line is like, once you have such a technology, you can use it to organize societies beyond face-to-face communication. And this has been from the very beginning also going along with environmental destruction, in this case in Sumer, with water technologies that increase productivity on the one hand, but also led to salination, and by this also to the loss of agricultural productive area. And then the first feedback processes, which are information feedback processes, were central for industrialization. So actually coal, industrialization and coal are often equalized. And it's true that without coal, industrialization would not have happened, but coal was known before, but the difference is it could have been organized into issues like electricity grids and steam engines, which always made use of feedback technologies, information feedback technologies, that of course from now look like quite primitive, but already had principles built in of automatic control. Now, big jump forward. What about like the issues on equality? I will explain a little bit later why I'm talking about equality here. We know that it has a number of different issues and impacts on a number of different routes. There are more opportunities for developing countries to contribute to global markets, and there are also ICT-based rationalizations in labor-intensive processes. One important thing is like there are an increasing number of robot installations in OECD countries, which actually take back manufacturing jobs from industrializing countries back to OECD countries. We know on a national level there's a resultant polarization of income substituting middle-class jobs. That's empirically shown, especially for North America. It has been, there are more ambiguous results for Europe, mostly because also of different social welfare net configurations. There's a supply side issues mostly associated with mining, with a number of detrimental impacts of local population. And then, of course, on the consumption, there's also distributional issues, because in the developing world, most people still don't have access to digital technologies. There's a second contextual issue, which is polarization. I will explain again why I mentioned this here in this context in the next slide. But the main point is we have monopolistic data platforms that optimize their business model by increasing user staying time on their platforms. And this is done with a lot of behavioral nudges that are AI controlled. It also involves like political opinion formation, which actually reduces agency by polarization. And then there is like the environmental field, and the bottom line is basically, yes, there are good sides of AI, for example, rapid integration of renewables, vehicle-to-grid technologies, and shared pooled mobility. But there are also bad sides of that, which is the energy use in data centers, the AI use for oil field exploration, and the unlimited deployment of autonomous vehicles, which actually will increase greenhouse gas emissions and also other more problematic environmental dimensions that are related to land use. So it's neither bad nor good, to paraphrase Shakespeare, but, and that's the point, regulation makes it so. Like, just to forward one of the key messages, shared pooled mobility and autonomous vehicles, they can contribute if, for example, they're used in suburban environments as a substitute for the private car. If autonomous vehicles are used in more ex-urban environments to actually increase urban sprawl, to have longer distance traveled in car mobility and longer times, this will also make emissions higher. And so it's very important, like upon the introduction of autonomous vehicles, which is now, to introduce regulation on their usage. Why I'm talking about all of these different factors, which is equity, political agency, and climate change, or more broadly the political stability issue, because they are related. And their main point is that both equity and political agency, like polarization, are decisive factors when it comes to the ability of political systems to address climate change and planetary stability. If societies are unequal, there's less social trust. If there's less social trust, it's harder for governments to decide on politically effective instruments. Same is true of polarization. If societies are more polarized, it's hard for governments to forward any politically effective instrument, such as carbon pricing. It's empirically validated, and in that context, like this, digitalization's impact on these other dimensions are actually indirectly highly important for climate change and sustainability. Okay, one way to think about it is that we also, when we think about like the contribution of digitalization, for in this case for climate change mitigation, it's equally important to look there on the impact on equity and on political agency, to look at systems and governance of digitalization that enables also like a more, like a less radical development of inequity that we have currently observed globally, but also at the contribution of digitalization to actually stabilize political systems, something that's not happening currently. More abstractly, like there are like now leverage points related to digitalization, which is really about, and this comes from Donella Meadows, it's about the rules and feedback that are used to govern AI, for example. It's about the information flow. So can we create an epistemic web to support Earth system understanding? It's about the goals. So what are the aspirations that we are following? And then the mindsets that are really about like where do we understand ourselves in terms of like our tasks. There's currently already a good understanding, and I'm breaking it down like explicitly now to what can be done And perhaps what you're also interested in, where AI can contribute to, in this case, climate change mitigation. It's in the residential sector. It's like basically direct information feedback on energy use, the information that can and should be also correlated with monetary incentives. And so this is like a valuable goal. It can, like in average on large scale meta-analysis, has an effect of 2 to 4%, but in specific instances it can have like 20% reduction in energy use and greenhouse gas emissions. Like one important example is, for example, warm water. Like warm water is one of the key reasons or underlying drivers of gas use in households. Direct displays in shower heads on the use of warm water can decrease energy consumption by 20% on this particular appliance easily. Smart mobility, key issue here is like that some smart mobility options are harmful for the environment, others are beneficial. Of course, it depends on the factors of energy use per person kilometers. Like you can have two strategies here. One is like decreasing the size of the vehicle. So go micro mobility, go for e-scooters, which are very small. So this is beneficial for, like, of course, they're not so long distances. The other is like, think about cars. Cars are used in average by 1.1 person for about 2 tons of steel. It's, of course, and then the motor is again like an efficiency of 20%. Like it's like one of the most inefficient devices humanity ever invented. So, but you can increase efficiency if you increase occupancy of cars by a factor of 3 to 4. So if you have an average 3 or 4 people in a car, then you actually increase energy efficiency by the same factor, and that basically means shared pooled mobility. So you're actually pooling rides, and you can use smart routing, which is of course a digital technology. It's a traveling salesman problem. You don't need specifically AI for that, but computing power definitely helps. Then we have smart cities, and smart cities, the main point here is that there are a number of different applications. Many claim to be sustainable, not all are. So it's very important to differentiate between claims and actually impact. One opportunity that we see here is for urban planning, to have a very rapid urban planning that is evaluated according to greenhouse gas emission metrics, air pollution, and other sustainability dimensions. Skipping that slide and going directly to the urban example that we're currently having for Berlin. This is our analysis of how urban form, which is like the street network, population density, distance to city centers, and other factors, how these kind of factors influence travel distance in vehicles. You can see a strong nonlinear effect. So like the size of the bars corresponds to the travel distance induced by the urban form specific setting, and you can see that outer districts obviously are driving much longer than inner districts. It's a nonlinear effect because in a district you actually don't need a car necessarily. It's also important to contextualize in terms of social demographic issues, which is color coded here as income. So like it enables more targeted interventions. Can upscale this approach by, for example, here, artificial neural networks to identify which part of this city and what kind of contextual variables are important to reduce greenhouse gas emissions and energy use in transport and in buildings, which you can then use for predictive modeling to identify in which part of cities what kind of additional settlements and apartments actually inducing what kind of greenhouse gas emissions. So basically, it enables a rapid evaluation of like how urban planning can minimize additional greenhouse gas emissions. In this case of the city of Porto in Portugal explains that TOD, which is transport-oriented development, can deliver most for reducing greenhouse gas emissions. So main point here also for cities, it's not like if you think about what cities are usually doing, cities are regulating space. They're telling like where new buildings will be, how building sector will be regulated, how street space is allocated. So this is like cities about infrastructures and about the spatial dimension of infrastructures. Now, what's coming here is that an additional layer of data is coming on top of the physical infrastructure. So there's a digital infrastructure on top, and these needs to be aligned. What's happening currently is that digital infrastructure is not in the hand of the cities themselves, and they neither have the data available nor the capacity. And the key is now to align that so that cities have the capacity, because actually they know best how to deal with the infrastructure, but the data infrastructure is needed, and it's important to get to an alignment here to enable cities to fast forward low carbon urban planning and transport planning. So to summarize, use AI-based urban planning to avoid high energy consumption, improve energy efficient mobility services, and then in the larger picture, shift and accelerate mitigation pathways. So in a sense, like you can use AI to actually accelerate the deployment of existing solutions, but also to develop and get new solutions on the ground. Again, it's not primarily a function of technology and of new ideas. It's really a question of governance, and that's really my major message here. Thank you.
Thanks, Felix. That was really enlightening. One question that I want to ask, and I'm not from the policy side, so forgive me, but developing countries are sort of demanding, and I am from India. So they are demanding, especially India that I know of, is demanding of the developed countries that they provide some sort of almost climate reparations, if I would, where they're saying that you need to offset because the developed countries have used so much of the greenhouse emissions, and they are. So how do you think that plays out?
Restitutions, climate restitutions, yes, it's a very different issue. I think, it's so there's a so-called carbon budget, and the question here basically is how the carbon budget is allocated, whether it's purely future-oriented or whether it's also historically oriented. So there's not one-to-one clear answer. However, whatever allocation mechanism you use, it's quite clear that because of the not immediate application of climate change mitigation in rich countries, that there is an instrument, like a distributional issue coming on top of what is happening. And that means at least that developing countries like India can demand financial support for their own mitigation, for example, by technology transfer, but also by corresponding agreements, for example, international carbon trading, that in the sense that, for example, countries like Germany don't mitigate fast enough, that they can buy carbon credits for mitigation effort in India. So there are justifications on an ethical basis for that. One important thing is that there's not a way the rule of that, of how to allocate the carbon budget, is of course a political issue, and there's no unique answer to that question.
Thanks. Other questions?
Hi, Felix. This is Wenbo. Very interesting presentation and very impressive. So my question is on the data side of the work you're working on. So you mentioned I saw that in your slides there is some like illustration of the AI's power on the sustainability. So my question is that in the real analysis, how will you be able to identify the effects of the AI's power only from the other development of the technology? Let's say that we can see some reduction in the greenhouse emission. So that's probably due to the AI, or it could also be due to the development of the vehicle technology, right? So in the observational study, is there any tips to identify the effect from AI only? Yeah, that's my question.
It's a very good one. Evaluation of mitigation effect of AI technologies are extremely hard, and allocation of that, for example, as done technically by life cycle assessment, is notoriously challenging. So one way to think about it, it's about a contributing role of AI to technologies, like an enabling role. So it's not a direct attribution then, but that AI can support another technology. Basically AI is also understood as a general purpose technology. So it's going all around as an additional layer of technology on top of existing technologies. And then it has this enabling character. And that is supportive of identifying the good applications, because you can look into existing assessments of, for example, technology or technological system where they make a contribution, for example, for climate change mitigation and other purposes, and then go into supporting these technologies with the AI. That's a very useful way of looking at it.
I see. Thank you.